front can come out, hit the ground, and really move at high speeds to move that air mass out of there, which means that I can pick up those heavy wind speeds up over 58 miles per hour fairly easily in a supercell. The other thing that will occur, because I have this really clearly defined wind gust occurring, right? This gust front, and you can actually see the front that they drew here, right? This cold front. It also means that I will see a nice, clearly defined shelf cloud occur, which means that the chances of getting a rolling cloud between the two is pretty high when I have a supercell. And like I said, when I get a rolling cloud, I will put out a tornado watch. And watch is the first stage. When you're going into any of these major storm events, whether it be a nor'easter, a hurricane, a thunderstorm, if you hear the word watch, it means that we're watching out for the storm itself. If you hear the word warning, it means it's coming. There's no, it's not, warning is not like there's a chance. Warning means it's coming. So if you're in the watch zone, it means maybe. And if you're in the warning zone, it means it's on its way. You've been warned, get ready, or evacuate, or do whatever you need to do. So just keeping track of those terms in our forecasting set. A little image of a hook echo. So notice this dark red in here, which is the most severe part of the thunderstorm, and you can see that it's actually rotating, so it's supercell. And when I have a supercell and I see a hook echo, it means that I have a severe amount of thunderstorm accumulation in a rotational air mass. And I will see in my images, in my satellite images, I will actually see the storm itself create this hook in its directionality, and that's because it's spinning on itself and it's doing it. It's producing this image back on its set. So hook echoes are a distinctive way to tell what is going on in the storm events. This brings me to those air masses that are coming out, so that downwards gusting can do what's called a downburst. And a downburst is when I get these little rapid releases of air mass that comes out of the cloud, hits the ground, and spreads out in all directions. And it will do this at incredibly high speeds. So I can have gust fronts going on the whole time. Gust fronts, like 30 mile per hour gust fronts. And then all of a sudden I can get what's called a downburst, which is this exceedingly heavy amount of air that just comes speeding down from the cloud, hits the ground, and just goes out in every direction. And in order to do that, I must exceed 165 miles per hour. They're incredibly deadly when they do occur. And it's something that we are always watching out for when we see things at airports. Downbursts and microbursts are two of the scariest things, because if a plane is trying to take off or land and it gets hit with this gust, it'll push the nose or push the tail in and down, which can make it crack against the ground or actually flip the plane. And so it's one of those. And if you're ever at an airport and you notice as you're taking off that there's a bunch of flags on the ground set, that's actually so that somebody who is flying the plane can look for directional change or speedy change and attempt to rectify the situation before it ends up in a disaster. And so there's other uses for some of those silly things that you're seeing around you. Brings me to a derecho. A derecho is a straight wind. This is actually a downburst that comes out on a slight angle, so that when it hits the ground, when it hits it, it actually continues in a one-directional angle. So it's keeping that incredibly high speed, but it's not going out in every direction. So a downburst, think of like if I was to drop a little bit of water into a pond and it radiates out circularly. A derecho is when I actually push it down on an angle so that when it hits the ground, it only goes out in one direction. So all that energy has one direction as it goes through. And these things can persist for a very long amount of time. And so they can actually go forward for like an hour's time. So I can have this one air mass moving at 100 miles per hour, just moving forward at 100 miles per hour for like an hour before it runs out of steam in its direction. A microburst is a downburst that does not go very far. It is only traveling less than 2.5 miles away from its actual place of downburst location where it hit the ground. And here is just some images that gives you a little feel for all this directionality of wind as it's moving through. Bringing me into another concern. When we have thunderstorms, because they're incredibly rapid, so they build rapidly, and then the event takes place so quickly, and it can dump such heavy amounts of moisture. So it's a really tall vertical cloud, right? So I'm carrying a lot of moisture, a lot of humidity in that cloud, which means that I have the potential to rain out several inches of rain in a very short amount of a time. And so in 3 hours' time, I can go from having a hot, dry climate that hasn't seen rain in a week and a half to a place that just got 3 inches of rain on the ground. And there's no place for it to go, which causes flash flooding. That ground was dry and it's cracked and it's impermeable because it's so dry. So it doesn't have that spongy ability that soil normally has to absorb all that water. And so it just pools on the surface, right? And has nowhere else to go except for downhill. And so it pools, and then it gathers, and then it runs. And so this is one of those big concerns when I get thunderstorms coming through. I can get those really rapid flash floods. And we've even seen it in the New York region where we'll get that really bad summer rain that comes through, and it only lasts 20 minutes. But the actual wastewater system, the drainage system in the streets can't handle all the water that's trying to get down the drain pipes. So it's trying to move into the drain on the street, but it can't. So it floods up in the drain because it just can't even move rapid enough through the drainage system. And so I'll end up with flooding on the roads and in the little road corridors all around Valhalla in one of these major rain events. As far as the distribution of thunderstorms, there is about 14.5 million thunderstorms occurring each year across the globe. And thunderstorms have statistically gotten more severe as well. So in the last 20 years, we have seen thunderstorms occurring more rapidly and with greater strength than we have in previous years. So not only are they frequent, their strength during that frequency is increasing. And we can also see some of the places where we get really frequent thunderstorms. Another thing to keep in mind is some of these thunderstorms are part of the natural cycle. So in some locations of the world, and I'm thinking of these regions over here, in the southern parts of Asia, this is part of their season. They have a wet season and they have a dry season. And so they do expect these sort of rain events to keep occurring. And it's not day 12-hour rains. This is like an afternoon storm that just pours down and an hour later it's done. But it happens again the very next day. And so we have this natural cycle of rain occurring. And that's actually becoming more common in southern parts of the United States. And this is becoming something normal for the Florida and other regions along the Gulf Coast there. As far as data and cloud-to-ground lightning flashes, there has been a standard set. And you can actually see cloud-to-ground lightning flashes in the pink and PMs to AMs in the blue. And you can see that they have places that they tend to centralize more often than not. I'm going to actually stop here and pick up with the next part video, the part 6, to start talking about tornadoes.